Hi, hello, this is Thiruma from Department of Aeronautical Engineering, Hindustan Institute of Technology, Coimbatore. Let me see the seminar topic named Nanotechnology in Aerospace Application. In aviation industry, the nanoscience technology is mainly focused by NASA and by commercial and military aircrafts and aero technologies. And these technologies were used to improve electronics, improve paints and sealants, carbon nanotubes. And the roles which we based are electronics, production, advanced material research. Let us see nanomaterials for aviation industry. Nanotechnology is recognized as a very strong innovation driver and is therefore seen as a strategic technology for the world's future economy. Nanomaterials with their exceptional multifunctional properties may transform the functioning of aviation industries dramatically. The science which we called nanotechnology and the materials for different sectors of aviation industry. The success of aviation industry depends on various factors ranging from relation of weight, availability of materials with multifunctional properties, eco-friendly fuels, less fuel consumption, faster and highly responsive communication system, less or no repairs, extended and safe life, reduced time frame of development cycle from concept to implementation. Nanomaterials can be primarily used in three areas of aviation industries. These are listed below. First one, airframe structures, aero engine parts, and then aircraft electro communication system, and many more. Nanomaterials used in airframe structure. Properties of materials required for airframe structure. The design requirements of the materials to be used in airframe structure are they are going to be lightweight, high strength, high toughness, corrosion resistance, easy repairability and reusability, less maintenance and durability. Nanomaterials which can fulfill the requirements. The modern aviation design requirements like faster, miniature, highly maneuverable, self-healing, intelligence-guided, smart, eco-friendly, lightweight and shield system warrant for material with extraordinary mechanical and multifunctional properties. Nano coatings for aero engine parts. Basically, coatings are used to prevent corrosion, which from oxidation of air from atmosphere and moisture and like this go on. Mainly coatings are used to prevent materials from rusting. In nanoscience, using of microparticles have to involved in corrosion process to prevent materials. Let me see the technical definition. The coatings are generally used for protecting the structures and surfaces of the aircraft from harsh environments. The stringent requirement like resistance to extreme temperatures, extreme climates, corrosion and absorption and wear of engine parts have sparked an increased damage for more reliable high performance coating, and some nanomaterials coatings with improved high temperature properties may allow higher engine operating temperatures and therefore improved performance in the future. SiC nanoparticles in SiC particles, reinforced alumina, yttria, stabilized nano zirconia, and this process can facilitate crack healing, resulting in improved high temperature, strength, and creep resistance as compared to monolithic ceramics. Tin nanocrystallites embedded in amorphous Si3N4 are used for resistance coating. The nanocomposite coatings made of crystalline carbide, diamond-like carbide, and metal dichalco lightning. Tin are used for low friction and wear resistance applications of aircraft. Nanotube and nanoparticles, that is nanographite and nano, which belongs to nano, which is microparticles. Aluminum containing polymer coating are used for electrostatic discharge, EMI shielding and low friction applications of aircraft surfaces. Next topic, we are going to see nanomaterials for aircraft electrocommunication components. CNTs have unique set of properties including basaltic electron transport and huge current carrying capacity, which make them of great interest for future nanoelectronics. Magnetic nanoparticles, that is iron oxide nanoparticles, example Fe2O3 and Fe3O4. Incorporated polymer films and composite can be used in various data storage media. Ceramic nanoparticles like barium titanate, barium strontium, and titanate used for making supercapacitors. MEMS, micro electromechanical systems, and NIMS, nano electromechanical systems, offer the possibility of developing a standard fuel management unit which controls the fuel control in aero engines. And nanomaterials for energy storing devices and capacitors in aircraft and aerospace science. Carbon nanotubes, CNTs, have been long heralded as potential candidate for hydrogen storage device. CNTs release hydrogen in a controlled way to generate power. Ballistic armors provide protection to the personnel and aircraft from various projectiles. And the composite materials, the advanced composite materials in aircraft structures and manufacture. Even the composite materials can take place in nanoscience and technology, which is used in aircraft and science. Nanotechnology takes aircraft manufacturing out of oven. Nanowork news, composite materials used in aircraft wings and fuselages are typically manufactured in large industrial sized ovens. Multiple polymer layers are blasted with a temperature up to 750 degrees Fahrenheit and solidified to form a solid resilient materials. And this is the picture which represent the composite materials used in aircraft frame structures and manufacturing industries. This structure is made up by composite materials by nanotechnologies, and we are going to see applications of nanotechnologies, where we use, why we use, what are the purpose, and why we need to use that in aeroscience, aerospace, like this. First of all, coating. Already we saw that coating is used for coating is a process used to prevent corrosion. Okay, and coatings are used for color design, exterior top coats, intermediate coating, premiums, corrosion inhibitive coatings, interior coatings, fuel tank coatings, wing coating, fuselage connective coatings, anti-cave coatings, and so on. And this is the picture represented for the applications of coatings by using nanotechnology. This is the picture which is representing the structure of composite materials used in aircraft manufacturing industries and the structure followed by aerodynamic forces. And this is even used in aeroscience and aerospace and like that, and so on. This is the picture used for coatings for corrosion prevention. This looks like a glassy one, and also used for dicing and nanotechnology applications. National security, high sensitive low power sensors to detect threats, low weight lightweight military platforms, reduce carry-on weight of soldier gear. One of the most advantageous thing of nanotechnology is to reduce weight and faster, better and cheaper than other materials. In space, props for planet surface, micro rovers and spacecrafts, etc., and also used to design the space suit used in space. This is the pictorial diagram which represents faster, better, cheaper space transportation with the nanotubes, and the parts are and then nanotechnology process used to make lithium batteries and fuel cells, TPS elements, digital nanoelectronics which is computerized, and composite aeroshell and hydrogen storage and integrated aerospace engines and electronically operated flight, this known as smart materials. And then last, micro electrochemical systems, which is known as MEMS and NEMS. Application of military plays a major role in aviation science. Nanoscience, even nanotechnology can apply it for military applications, which are conductive coatings to be used on jet fighter canopies. Canopies means which is a glass coating covering used to cover cockpit. Clear bubbles that cover planes cockpits for the US Air Force. Coating will improve electromagnetic shielding and electrostatic discharge to prevent electronic disruptions. And then thank you.